This video, we want to prove this theorem. We need to be careful about what it says. It says that if this set, v1 through vn, is a set of non-zero vectors in vector space V, such that every vector in V can be written in one and only one way as a linear combination of vectors in S, then S is the basis for V. Now, to show that S is the basis for V, we need to show that S spans V and that the set S is linearly independent. The fact that S spans V is given. And why is it given? It says that the set S is such that every vector in V can be written in, I don't care if it's that it's one and only one, but it can be written as a linear combination of vectors in S. Every vector in V can be written as a linear combination of vectors in S. Hence, S spans V. That's given. So now we need to show that S is linearly independent. Now we're going to take into account that every V can be written as one and only one way as a linear combination of vectors in S. Okay, so now somehow we need to go from here. Suppose A1V1 plus A2V2 all the way down to ANVN. Didn't know how to do this proof until just now. Equals 0. Okay. But 0V1 plus 0V2 all the way down to 0Vn is 0. Okay, that is, I wrote the vector 0. I wrote the vector 0 as supposedly two different linear combinations of the vectors in set S. Hence, A1 equals 0, A2 equals 0, all the way down to AN equals 0. You can't have two different ways of writing any vector in V using linear combinations of vectors in S. You can use other vectors to get a linear combination for little v, but not from the vectors in S. Okay, so since that implies that not going to write that. Since all the coefficients have to be 0, that implies that S is a linearly independent set. So, we show that with respect to vector space V, S is linearly independent and S spans V. Therefore, S is a basis for V. If you love videos like this and you have the person doing the proofs, thinking it out right on the spot, letting you see how you think about these proofs, subscribe to my channel. Writing proofs is their talent, and I'll say one thing, my talent has grown a lot since I've been working on this channel. My proof techniques have really improved. I mean, possibly you can see that if you look at my earlier proofs. Most of all, It's a great channel to be part of. Subscribe and watch and learn. See you in the next video.